Hi, and thank you for joining. Here we are looking at another trig equation. So we have 2 sine x cosine x equals cosine of 2x, where the unknown angle x appears in every trig ratio in the equation and is an angle between 0 and 2 pi radians. So a couple of problems we're running into here is number 1, the angle x in the left side of the equation has a coefficient of 1, and on the right side of the equation has a coefficient of 2. So remember that when we solve trig equations, we solve first for the entire angle inside the ratio, which means that we have to solve for angle 2x, and we have to solve also for angle x, which makes it impossible to solve the equation because we cannot solve for two different variables in a single equation. So number 2, as you can see here, x appears in different trig ratios, so it appears inside a sine and a cosine ratio. And again, we need to have the same trigonometric ratio throughout the equation so that we know which trig ratio to use for the unknown we are solving for, in our case for x. So trying to solve the problems one at a time, we are going to take a different approach and take a look at the left side of the equation and see what we can do to transform this. You probably recognize a popular formula here, 2 sine x cosine x, which is sine of 2x. So we can replace the left side with sine 2x, and the right side will stay the same, cosine of 2x. So as you can see here now, at least we have the same unknown that we are solving for initially, so the angle 2x. So the angles are the same. Now, the second problem we said is the fact that we have different trig ratios. So we prefer to have the same trig ratio throughout the equation. So we must be thinking, what connects sine with cosine? Well, the first formula that always comes to my mind is sine squared plus cos squared equals 1. However, in this case, this won't apply because we do not have a square term here, a squared cos or sine. So we're going to give up this idea, but we thought about it. So next we have to think what other connections exist between sine and cos. Now, sine and cos are related to each other by the ratio of tan. Remember that tan theta equals sine theta over cos theta. So what that means is that in some ways, if we can put them together so that can make tan, then we will have hopefully a single ratio in the equation. So remember that in an equation, as long as we apply the same transformations to both sides of it, we still don't change the value of it. So the equation will be equivalent to what we had and it will have the same solutions. So in this case, what we are going to do is divide both sides of the equation by cosine of 2x so that we can create the tan ratio on the left side. And obviously we have to do the same thing to the other side of the equation, to the right side. And the left now will convert to a tan 2x and the right side equals 1. So this is one easy equation to solve. At least we have practiced solving such equations. And we are solving, remember, for the angle 2x. So always find all the solutions for 2x before solving for x. Now remember that the domain of the angle x is between 0 and 2 pi. And since we are solving for 2x first, then we are going to say that double x will be between, we are going to double each side or each end of the domain. So 2 times 0 and 2 times 2 pi. So that will make the domain of angle 2x between 0 and 4 pi. So step number 1 now to solving the equation would be to solve for 2x. So we have to find all the possible values of 2x that have a tan ratio of 1 within the domain from 0 to 4 pi, which is the domain of 2x. So if you use a calculator set to degree mode, then the calculator will probably give you the 45-degree angle. And we have to quickly convert this to radians because our domain is described in radians. So once you find your first angle, draw the terminal arms of all the angles that have the ratio of tan equal to 1. So first, we are drawing the angle the calculator gave us, so the angle pi over 4. So this will be our first solution for angle 2x. And since we use the ratio of 10, then we are drawing the second terminal arm by extending the terminal arm on the opposite quadrant, so towards the opposite quadrant. And here goes the next angle. So again, count them: 1 pi over 4, 2, 3, 4, 5 pi over 4. So 5 pi over 4 would be this green angle here. So remember that our domain here is 4 pi, which means that so far we have traveled 2 pi radians and hit the terminal arms once. And these two will be the first solutions. So I will write them down. Let me color code them as well, because why not? So the next solution would be 2x equals 5 pi over 4. Now, because the domain is 4 pi, it means that we can go around the circle here one more time. So another 2 pi radians. So we're going to hit the pi over 4 terminal arm. So this terminal arm one more time. Remember, we're simply adding a 2 pi. So we're going to say that angle 2x can also be pi over 4 and another 2 pi, which makes it 2 pi is 8 pi over 4, so 9 pi over 4. So there goes our third solution for x. And similarly, we are going to obtain the fourth solution. So 2x equals 5 pi over 4. Now, if you go around the around the circle in the Cartesian plane, up to 4 pi radians. So we're going to hit the angle 5 pi, the terminal arm of this angle, one more time by adding a 2 pi to it. So that makes the angle 2x equal to 8 plus 5, 13 pi over 4. So once we have determined all the possible angles 2x with a trig ratio of 1, then we can start solving for x. That should be our very, very last step. So if 2x equals pi over 4, it means that we will have to multiply both sides of the equation by a half, right? So that can eliminate the coefficient of 2, or divide both sides by 2. Same idea. So this will give us our first solution, x equals pi over 8. So that's a solution for x. So next we have 2x equals 5 pi over 4. Now we know the drill, so we are simply multiplying by 1/2, which is simply increasing or doubling the denominator, which means that x must be 5 pi over 8. Next we have 2x equals 9 pi over 4, which means x would equal 9 pi over 8. And lastly we have 2x equals 13 pi over 4, so isolate x, and we get 13 pi over 8. And voila, here are the 4 solutions to this equation. So I hope this made sense and it was helpful, and the explanations were helpful. And thank you for following me. Bye for now.